So in this video, we are going to be talking about the concept of counting. So there are a few concepts here that we are going to discuss. In this first video, we are going to be talking about the first two, which are product rule and sum rule. And in the upcoming video, we are going to look at the other two concepts of permutation and combination. Now, the reference for these concepts, you can actually find it in this particular book. And we actually have given you access to these particular sections in the book, Chapter 6, Counting of Discrete Mathematics and its Applications. You can actually find a scanned copy available on eLearn. Now, you may ask, why do we count? So as we have discussed earlier, one of the things that we are interested in is to be able to characterize the complexity of a given problem. And in this case, complexity is expressed in terms of how many operations will be undertaken by a particular algorithm. Now, let us see an example. So in this case, we brought this up in the week 1 introduction. We talk about how many possible routes are there. For example, if you're trying to design the torch relay for any given Olympics. And in this case, it's an example from the 2012 Olympics where there are 33 cities. And if we look at the number of possibilities that we need to examine in order to identify the really optimal answer, and the optimal answer here could be one of the least distance, or the shortest time, or the cheapest. But in any case, we need to look at 33 factorial or possible permutations. So clearly there are many possibilities there, and we want to be able to characterize this kind of possible answers for the different problems that we are going to be seeing in this course. Now, let us first start with product rule. Now, in the case of product rule, we are looking at m ways to do one thing and n ways to do another thing, and therefore we are going to have m times n ways of doing both things. Now, in this case, we actually want to do both things at the same time, and therefore we need to multiply the number m and the number n, because these are the number of choices that each thing has. Now, let's look at an example. So SIS has 2 floors with seminar rooms, and each floor has 4 seminar rooms. Now, how many seminar rooms are there in SIS? So we can think of this in terms of doing 2 things. One thing that we need to do is to pick a floor, and there are 2 choices here. And the other thing we need to do is to pick a room within a floor, of which in this case there are 4 choices. So for us to identify a specific room in a specific floor, we need to pick both a floor and a room, and in that case there are going to be 2 times 4 equals to 8 ways of finding a seminar room. Now, for another example, we are going to be looking at a binary string. Now, a binary string essentially is a string of numbers, but the numbers can only be 0 or 1. So 0, 0, 0, this is a binary string, for example. Now, we are looking at binary strings of a fixed length n. How many possibilities are there? Now, if the binary string has a length 3, then we can enumerate all the possibilities. So 0, 0, 0 is one possibility, 0, 0, 1 is another possibility, 0, 1, 0 is yet another possibility, and so on. And if we keep doing this, essentially we can identify 8 different binary strings of length 3. So we can think of the problem in terms of having a slot for 3 binary digits. The first one, the second one, and the third one. And for the first digit, we have 2 choices, because we can either pick a 0 or a 1. Now, the second digit, we can again have 2 choices, a 0 or a 1. And the third digit, we can again have a 0 or a 1. So in that case, so if you have 2 by 2 by 2, which is 2 to the power of 3, which is equal to 8 possibilities. So for n bits or binary digits, we have 2 to the power n possibilities. Now, this is a product rule, and in the case of product rule, we multiply them because we actually want to do all the things that we have choices for. Now, sometimes we are not trying to do all the things, but we are just trying to do one of the things. And that is what essentially is covered by the sum rule. So sum rule says that if there are m ways to do one thing and n ways to do another thing, and both things cannot be done at the same time, so we can only do one thing, And so there are m plus n ways of doing one of the things. Now, let's look at some examples again. So you can go to one of the 4 seminar rooms in level 2, or you can go to the 4 seminar rooms in level 3. Now, you cannot be both in level 2 and level 3 at the same time. So you will be doing only one of the things. In fact, you'll be going to only one specific room. So how many possible rooms can you go to? In this case, it's 4 plus 4. Because we are going to go to either a room level 2 or a room in level 3, but not both of them at the same time. So based on the sum rule, it's 4 plus 4 equals to 8. Now, for another example, supposing that you are looking for a final year of FYP project from 20 projects offered by industry, 10 projects offered by professors, or to propose your own project. Now, how many possible projects do you have? Now, in this case, you're only looking to do one project. So you have a choice of one of the 20 that is offered by industry, or one of the 10 that is offered by professors, or you can create your own project. In this case, the number of possibilities are 20 plus 10 plus 1 equals to 31 possible projects. And this is because you will only be doing one of the projects at any point of time. Now, sometimes we cannot just use these rules in isolation, because some of the more complex problems, in fact, require both of them. Now, what are some examples of that? So, an example of that is, for example, when we are trying to look at numbers that can be divisible by a certain number and numbers that are divisible by another number. So this is what we call an inclusion-exclusion principle. If there are two things, and the two things can be done at the same time, then the sum rule will lead to double counting. So in this case, we add the total number of ways to do each task, and then we subtract the number of ways to do both tasks at the same time, because these are the numbers that are actually going to be double counted. Now, this is going to be clearer when we actually look at this example. Now, let's say we are looking at numbers or integers from 1 to 1000. And we are asking how many of them are multiples of 3 or multiples of 5. So we can first count the ones that are multiples of 3. So multiples of 3 are 3, 6, 9, 12, 15, and so on. So if you're looking at the number of possible integers of multiples of 3, from 1 to 1000, then we can just divide 1000 by 3. So we're going to have 333 possible number of integers. Now, again, we can do something similar to multiples of 5, 5, 10, 15, and so on till 1000. How many such integers are there? It will be 1000 divided by 5 is equals to 200. So now if you're looking at multiples of 3 or multiples of 5, then we can sum the numbers, right? This is an application of the sum rule. So you will have 333 plus 200. Now, this, however, is going to lead to double counting, because there are, in fact, some numbers that are multiples of both 3 and 5. So in this case, 15, 30, 45. Now, like you can see here, you can actually have 15 here in the list of multiples of 3. You can have 15 again in the list of multiples of 5. So 15 is counted within this 200. It is also counted within this 333. So when we sum them together, effectively we are counting 15 twice. So then we are looking for how many of them are actually double counted. And the ones that are double counted are the ones that are multiples of both 3 and 5. In this case, it's 15, 30, 45, and so on. Now, how many of them are there? So we take 1000 divided by 15, we get 66. So using the inclusion-exclusion principle, which is to take out the ones that are double counted, we have 333 plus 200 minus 66. So in total, the answer is 467. Now, this is introduction to the concept of product rule and sum rule. Next, we're going to be looking at some in-class exercises.